Okay, do you have them yet? Guys, chord. Does a chord leave the circle? Nope. Can it go through the center?
Yes.
Sure. Does it have to go through the center? No. All right, tangent. How many? Okay, pause. Back to chord. How many times does a chord intersect a circle? I heard once and I heard twice. Which is it? Twice, right? Edge to edge. So we've got intersection, intersection. Okay, tangent. How many times does it intersect a circle? Once, right? Interior, exterior? Exterior. And then I always draw my point first and then I try to hit that point. Helps me. Secant. How many times does a secant intersect a circle? Twice. Does it leave the circle though?
Yes.
Yeah. Is it a segment or a line?
Line.
Okay, so you have this. We got this. Intersects here, here. Call it good. So we have 3 formulas to go over. They're theorems, but formulas. You need to know the difference between chord, tangent, secant. These in here. So this blue part, this blue segment, this red segment, what vocab word? Chord. So if you have 2 chords intersecting in a circle, it's kind of fantastic. Because what will happen is you can break it into pieces. This piece times this piece will equal this piece times this piece. Out of the 3, I'd say this is my favorite. Break it into pieces, you can multiply them, they'll always equal each other, as long as they're chords intersecting in a circle. Okay, let me erase that and let's put numbers in here. Let's have another example besides what comes up later. So if this is, I don't know, 2, and this is 9, and this is 3, and this is x. I think you should write it in your circle real quick, and let's do this together. Break it into pieces. So this times this, 2 times 9. In a circle, if their chords will always equal 3 times x. That's what this theorem is saying. So what's 2 times 9? So 3 times what will give you 8? There you go. That's how you solve it. Okay. Not too bad? You okay with that theorem? Here comes the next one. The next one. Kind of the same idea, but you have to be careful. So this one, EB and CD, what vocab word would you use to describe those? Safest would be secant, because it's outside the circle crossing it. Okay, this one's a little bit trickier. This one you take this piece and you times it by the entire thing, this whole thing. You can't break this up into EA and AB. That's going to equal this little guy times this entire thing right there. So you just got to look at your picture and know which theorem to use. Do you want to stick numbers in again? Was that helpful? Kind of rough on the fly, but I can probably. Okay, is how about 2 and 10? Let me think for 2 seconds. And this is 8 and x. Okay, guys, set up. Get the numbers in there so you can look at it later. So this side, the orange secant. Solving this part, it would have to be 2 times, don't do 10, don't do 10, what is it? You gotta do the whole thing, 2 times 12. That's gonna equal, what if I switch this? Will that make you grumpy pants? I'm gonna make this one that 8 and this one the x. So this one 8 times 8 plus x. All right, what's 2 times 12? 24. So that's going to equal, wait. What if we leave this as 8 times 8 plus x and we don't distribute? Because, can you get rid of the 8 right now? How do we get rid of it, Tyler? Yeah, let's divide by 8 on both sides. That'll make it a lot nicer. Yeah, it will work out, not too sloppy. So divide by 8 right here to cancel that out. Divide by 8. Guys, you got this. What's 24 divided by 8? 3. So we have 3 equals 8 plus x. Oh, this doesn't work out. Why not? Dang it. All right, so we couldn't have a negative in there, but do you at least see the process of it? Okay, okay, don't worry. There's more examples coming up if you're still kind of wishy-washy with this one. Just remember, the thing that people get confused on is they just do this times this. Nope. Make sure you do this times the whole thing. Kind of the same. This might be my second favorite. Right here. On this one, you square that one. So you square the tangent. And then same as the previous there, this one you have to break into pieces. It's this first piece times this entire thing right here. I'm trying to think if I can brave putting numbers in this one. Actually, if we put x right here, that'll be okay. What if we put, I just have to put a number in and then think through it. What if we put 5 here? I've got to think of a, we're just going to have decimals. I can't do it on the fly. Let's do 5 and 9. Okay, so this one is saying take that x, square it. It's going to equal this piece 5 times the whole thing. What's the whole thing? 14. Yikes, what is 5 times 14? Is it 70? Alright, so we've got x squared equals 70. Guys, what would you do to get x? Square root it, do it. It's got to be 8 something, right? Ooh, good job rounding. Yeah. Okay, so that's it for today. Those 3 theorems, and now we're just going to practice them. Okay, so just, if you need to during your assignment, feel free to keep this page open. Oh, good! My favorite. So it's the chords on the inside. This one you can just break into pieces. You don't have to worry about using the whole thing. So this times this is going to equal this times this. So 10 times x, that's just straight up 10x. Guys, what? It's 8 times 5. Divide by 10, and what do you get? Do you agree? Not too bad? Nice, because you can just literally break it up into pieces. Okay, you ready for the next one then? Next one is an exterior example. Okay, we got this. Let's do it together. So be careful. Do this times the whole thing. So 12 times what? Yes, 12 plus x. That's going to equal this times the whole thing. So 15 times, what's the whole thing, guys? Perfect, 24. Okay, let's deal with this part first. It's 360. That's convenient. So 15 times 24 is 360. Let's just keep this 12 times 12 plus x. Be nice to yourself. Can you get rid of the 12 right now? Sure. What do you do? Good job. Divide it. So we've got 12 plus x equals 30. Can you do this in your head without a calculator? What plus 12 will give you 30? Yes! 18. X is 18. How you feeling about that one? You okay with that one? Not too bad? Okay, let's do our next one. Oh, okay. This one takes a little bit of work, but we got this. Do you remember what to do with this 24 feet from here? Perfect, write it down. So we've got to do 24 squared. That's going to equal, okay, on this there, we're still using this outside piece, right? So it's got to be this 9 times the whole thing. Be careful. Do you know? Yes, yes, 9 plus 2r. This 9, this r plus that r, that's just 9 plus 2r. I'm going to put parentheses actually. 9 plus 2r. Somebody have 24 squared yet? Nice. 576 equals 9 times 9 plus 2r. Again, is it okay to get rid of that 9 on the outside right now? Do it. Divide both sides by 9. What is it, Katie? 64? Perfect. So 64 equals 9 plus 2r. Okay, what would you do next? Perfect. Minus 9, so 64 minus 9. Is it just 55? Okay. So we have 55 equals 2r. Cut that in half, what's r? 27.5? Okay. Okay, how you feel about that one? You're okay with that one? Okay, this one and this. Okay, will you try number 1 and number 3? Try those before we give away how to do them. Alright, hold your conversations. Thank you for comparing. How many of you got 6 on the first one? You okay with that one? Okay, so number 3, how many of you got this set up? Okay, will you help me make sure you do this right? 15 squared is not just 225? Okay, so 225 equals 9 times 9 plus x. Help me out. What's 225 divided by 9? Oh, duh. Divided by. So then we get 9 plus x. Subtract 9, 16. How many of you got that?